Hello students and viewers, I take this moment as the prestigious one to present this video session as a present to you all. This is K. Venkatesan from Department of Physics, Bharathidhasanar Matric Higher Secondary School, Arakkonam. Now I am going to introduce a new topic in 12th standard physics, first unit. Subtopic is distribution of charges in a conductor. Say distribution of charges in a conductor. See, let us consider here two conducting sphere. The first sphere A and next sphere B. In the first sphere A of radii R1, the second sphere B radii R2 with respectively. Now the net amount of charge Q, the net amount of charge capital Q introduced into any one of the sphere, here plus Q charge introduce any one of the sphere. At that time this net amount of charges are redistributed into both the sphere. Yes, for example the 100 coulomb of charges, for example 100 coulomb of charges introduced any one of the sphere. At the time in this 100 coulomb of charges are redistributed. Here first 50 coulomb of charges and another one is 50 coulomb of charges redistributed. Okay, because in this two conducting sphere connected with one thin conducting wire. Thin conducting wire. See, this is a thin conducting wire connected with the thin conducting wire. So now in these two conducting spheres are EQ potential surface or electrostatic potential are same. Okay, see, this is a very important topic. The EQ potential surface, for example, the electrostatic potential at the surface of the sphere A is, this is a sphere, no, first sphere A, the next sphere we will take B. In this two conducting sphere connected with the thin conducting wire. Now the net amount of charge Q introduced into any one of the sphere, that time the charges are redistributed into both the sphere. Okay. Now the electrostatic potential between the two spheres are same. Okay. Here Q1 be the charge residing on the surface of the sphere A and Q2 be the charge residing on the surface of the sphere B. Okay. Now charges are redistributed because in these two conducting sphere connected with the thin conducting wire. Now electrostatic potential are same. What is the formula for electrostatic potential? Same, my dear students. Here VA, that means electrostatic potential at the surface of the sphere A equal to, that means VA equal to, what is the formula? 1 by 4 pi epsilon 0 into Q1 by R1. Okay. Here Q1 is the charge residing on the surface of the sphere A and R1 be the radius of the sphere. Okay, this one is radius of the sphere. Similarly, the electrostatic potential at the surface of the sphere B is, what is the value? Say, yes, VB equal to 1 by 4 pi epsilon 0 or epsilon naught into Q2 by R2, Q2 by R2. Okay, this is the another expression. Okay, here electrostatic potential at the surface of the sphere A. Here electrostatic potential at the surface of the sphere B. Now the two spheres are EQ potential, no. So applying this value, so VA equal to VB because in these two conducting sphere connected with the conducting wire. So VA equal to VB. Substituting this two value here, equate the two value, we will get the answer. What is the value? VA equal to, see, 1 by 4 pi epsilon naught into Q1 by R1, Q1 by R1, yes, equal to VB value. What is the VB? VB is here 1 by 4 pi epsilon 0 into Q2 by R2. Here Q2 is nothing but charge residing on the sphere B, R2 nothing but radius of the sphere B. Okay. Now equate the two terms. Here 1 by 4 pi epsilon naught cancel, here also 1 by 4 pi epsilon naught, both side cancel. Remaining What is the value remaining? Here Q1 equal to Q1 by R1 equal to Q2 by R2. Q2 by R2. Okay. Q2 by R2. Now, introducing surface charge density on the sphere A. We will take surface charge density sigma. Okay. Here also surface charge density, here sigma 1, here surface charge density of the sphere B is sigma 2. What is the formula for surface charge density? Already we know that surface charge density, what is the formula? Sigma equal to general expression charge per unit area. Charge per unit area. Sigma equal to Q by A. Now surface charge density on the first sphere, sigma 1 equal to Q1 by A. Next one is the surface charge density, second sphere, that means sphere B is sigma 2 equal to Q2 by A. Okay. Now substituting this surface charge density on the both the sphere. First sphere, surface charge density on the sphere A is sigma 1 equal to charge residing on the surface of the sphere A divided by surface area. Okay. What is the formula for surface area? Yes, surface area is nothing but 4 pi r square. Okay, 4 pi r square. So applying this value here, sigma 1 equal to Q1 by 4 pi R1 square. R1 square. We need charge only. Take charge. So Q1 equal to cross multiply this two value, sigma 1 into 4 pi R1 square. Okay. Similarly, Q2 equal to, what is the value say? Q2 equal to, yes, sigma 2 into 4 pi R2 square. R2 square. Okay. Here Q1 value is given, Q2 value is here. Q1, Q2. Substituting this two value, this equation number 1. Take this equation number 1 and equation number 2. Substituting equation number 2. Putting 2. Okay. Substituting equation 2 in 1. Already we know that Q1 by R1 equal to Q2 by R2. No. Substituting this value, equation 2 in 1, we will get the answer same. Here's value Q1 by R1 equal to Q2 by R2. No. So here Q1 value, what is value Q1 here? Q1 is nothing but sigma 1 into 4 pi R1 square divided by R1. Okay, equal to Q2 value. Q2 equal to nothing but sigma 2 into 4 pi R2 square divided by R2. Okay. So here R1 square cancel, R2 square cancel. Okay. So here both side 4 pi cancel, both side 4 pi cancel. Remaining term you want to write sigma 1 into R1 equal to sigma 2 into R2. Okay. This is the final expression. In other words, sigma R equal to constant. Sigma R equal to constant. Okay, this is the final expression. So in this expression, we conclude that, see, sigma inversely proportional to 1 by R. Sigma inversely proportional to 1 by R. This is very, very important relation. Okay, sigma inversely proportional 1 by R. So in this expression, we conclude that radius of the sphere is too small, means surface charge density is very high. Okay, here radius of the sphere very small, no. So surface charge density is very high. So in this radius of the sphere is very large, but charge density is very low. Okay, this is our conclusion. Okay, in this above equation we conclude that sigma is inversely proportional to R is nothing but radius of the curvature decreases, means is a very small, means surface charge density is very high. In this final expression we are applying action at a point or coronary discharge. Next heading, action at 2 points or coronary discharge. So action at a point or coronary discharge is a very important and interesting topic. See, listen here. First concept, action at point or corona discharge. Let us consider a metallic sphere. In the sphere is irregular. Okay, let us consider a irregular metallic shape conductor. This is charged conductor. Okay, in this conductor it consists of irregular shape. So one point sharp edge, another point should be broad. Okay, so in this metallic sphere is consist of n number of charges. Okay, now the action at point is nothing but, let us consider a charged conductor of irregular shape. Already one basic concept we know very well. The surface charge density sigma inversely proportional to r. The radius of curvature is very small, means here radius of curvature is very small, here radius of curvature is very large. Are you understood or not what I am saying? So here radius of curvature is very large means the charge density is very high, but here charge density is too low. Okay, compare this point here. In this diagram we conclude that the surface charge density sigma is inversely proportional to 1 by r. Radius of the sphere or radius of the curvature decreases, charge density will be increases. At the time the n number of charges at the edge, sharp edge, at the edge of the irregular body, in this point very high electric field is produces. Very high electric field. In this very high electric field get ionize the surrounding air. Here surrounding air, get ionize the surrounding air. At the time positive ions or positive charges repelled at the sharp edge. Positive charges repelled at the sharp edge. The negative charges are attracted towards the sharp edge. Okay. In this final expression, final statement conclude that the sharp edge, in this sharp edge the total charges are reduces, or the total amount of charges leakage at the sharp edge. This process we are calling action at point or corona discharge. Action at point or corona discharge. The major concept, the sharp edge charge density is very high because radius is very low. So at the time this very high electric field produce ionize the air. That means get ionize the surrounding air. At the time negative charges attracted towards the sharp edge and the positive charges repelled at the sharp edge. Okay, at the time total charges are reduces at the sharp edge, or total charge leakage at the sharp edge. So this is called corona discharge. Corona discharge, this is very important 2 mark in our board exam. Okay, define corona discharge. Simple concept, just you want write 1.5 lines. The total charges leakage at the sharp edge. In this process we are calling corona discharge. It's very easy, Yes. So basic concept, sigma inversely proportional to r. Okay. See one diagram, when I demonstrate. See here. Here sharp edge, here see sharp edge here. In this sharp edge it can be produce very high electric field. In this very high electric field get ionize the surrounding air. Ionize the surrounding air. At the time positive charges repelled at the sharp edge and negative charges are attracted towards the sharp edge. At the time the total charges leakages at the sharp edge. This process we are calling corona discharge. Are you clear? Yes, good. The next one is another example, action at point or corona discharge. See, this is a sharp edge. The sharp edge produce large amount of electric field, get ionized the surrounding air. Some of the charges are leakage at the sharp edge. Okay, this is the action at point. Another one example. Okay, next. Very interesting topic, lightning arrestor. See, final topic, lightning arrestor or lightning conductor. Okay, lightning arrestor, in other words we are calling lightning conductor. See, lightning arrestor construction and working. See here one by one. Let us consider here conducting wire. For example, first one, lightning arrestor is nothing but, it is a lightning arrestor is a device. It is tall building from the lightning strike. Say protect tall building from the lightning strike. In this lightning arrestor or lightning conductor works on the principle of action at the points or corona discharge. Action at the point or corona discharge. Okay. So that principle only applying here, lightning arrestor or lightning conductor. The lightning conductor is a device, no. In this device is consists of long thick rod. That means long copper rod. In this long copper rod passing top of the building to the bottom of the building. Okay. So in this copper rod already we know that it is a good conductor. That upper end of the copper rod is made up of, or upper end of the conductor as n number of spikes or short needle. N number of spikes, no, this is the n number of spikes. See, this is the n number of spikes. Okay. Upper end of the copper rod consists of n number of spikes, and lower end of the copper rod it consists of copper plates. In this copper plate buried deep into the ground. Okay. So the working of lightning arrestor is simple concept. When a negatively charged cloud, see here, when a negatively charged clouds passing over the building, negatively charged clouds passing over the building, at that time in the negative charges are induce the positive charge on the spikes. Where? Here, positive charge produces on the spikes. In this n number of positive charge get ionize the surrounding air. At the time corona discharges occur. What is the meaning of corona discharge? Some of the charges are leakage at the short pitch. Similarly, at the same time, in these positive charges attracted towards the negative charge from the clouds. Okay. So negative charges are attracted towards the spikes and the positive charges are repelled to the sharp edge. Okay. Now in these negative charges passing through copper rod or copper wire, and in these negative charges are neutralized. Negative charges are neutralized. Now in our building will be very safe. Okay. This is our construction and working of lightning arrestor. The lightning arrestor, the based on or works on the based on which one principle? Yes, action at the point or corona discharge. Okay. Dear students, I hope would have enjoyed this class. Dear students, I hope would have enjoyed this class, and I believe that it will be satisfy your thirst of knowledge. If you any doubt means contact us. Thank you.